Okay, so let's start with some of the questions from the multiplying the radicals. So this is the, oh, by the way, I talked to Professor Dawes yesterday, and then mentioned we're probably going to have a midterm exam via the website. So he will provide a midterm exam review, and then we'll go over that midterm exam review on next Tuesday, July 16th. Yeah, so that's our plan. Any question? Okay.
So the midterm will be on July 16th?
Yes. No, midterm is not July 16th. It's July 17th, next Wednesday, right? Next Tuesday, we're gonna review for the midterm. You just focus on reviewing for the midterm exam and go over some of the questions. You go over the review sheet from the website.
Okay. Okay. Thank you.
Sure. Yeah, see that. Yeah. So basically, you guys should try to have access to the website using the link I sent it to you, right? I think yesterday. Yeah. So you can use that link and get access to the whole system. I mean for the testing, right? You're trying to find. Okay. And any other questions? Okay. So all right. So we will start with the some of the questions from the multiplying, dividing the radicals. I'll start with this question right here. Okay. So you guys can try this one really quickly, and then I'll go over the solution.
Excuse me, sir. I want to ask when we will have the midterm.
The midterm will be July 17th. Will be next Wednesday, right?
Oh, okay.
We will review next Tuesday. I actually made an announcement earlier. So I talked to Professor Dawes yesterday. So he mentioned, we're probably gonna have a midterm via the website, and he will provide a midterm exam review via the website. So so we're gonna review for the midterm exam on July 16th, right, which is next Tuesday. And next Wednesday, you will take the actual midterm. Okay,
Okay, I get it.
okay, very good. Let me just quickly put it on in the chat. Yes, I put it in the note. Yeah. So right, finish. Midterm review. And then July 17th. It's the midterm. All right, so yeah, so let's get started. Let's go over the solution on this question here. So first of all, you distribute it, right? FOIL this. So FOIL. And start with the radical 2 times 6 radical 2. So radical 2 times radical 2 becomes 2. 6 times 2, which is 12. And radical 2 times positive, right? That's positive, so positive 4. Radical 11 times radical 2, that's radical 22. And we cannot simplify, right? Because 2 and 11, they are not perfect numbers. So we're going to leave as is. And distributing this, minus radical 11 times 6 radical 2 is minus 6 radical 22. And then the last term will be minus radical 11 times 4 radical 11. So plus minus, minus plus is minus. So 4. And radical 11 times radical 11, and that is 11. So basically radical a, right? Square root a times square root a becomes a, because it becomes square root of a squared, and cancel the exponent and the index, we get a. So we get 12 here, and combine the middle two terms. 4 minus 6 is minus 2, radical 22, and minus 44. Now combine like terms one more time. 12 minus 44, that's minus 32, minus 2 radical 22. Okay. So that's basically how we simplify this, how we get to the bottom of this solution. Any question about this?
No.
Okay. So minus 2 radical 22. Gonna check it. Right. So let's look at the question 5. Next problem. Radical x. Yep, we can try one of this. No problem. Okay, you try this, right? Give a shot. You guys try this.
Mister, I have a question.
Yes, sure, yeah, go ahead.
When I try to log in my web work, I can because the username and the password that you give me, I try with them, but I cannot do it.
You sure? You sure?
Yeah,
So,
I'm sure. Yeah, I tried last night 3 times, and I tried again now, but it's failed again.
okay, I'm gonna. So, did I enable the chat? Maybe I forget to enable. First of all, let me enable the chat. I may forget
Yeah.
to enable the chat. So, I'm gonna put in the username password in the chat, right? 1 second.
Okay. Thank you.
Yeah, sure. Go back here. Chat should be there. Though. I'm gonna stop share for a second, right? And then let me get to the chat. Okay, so right. All right. Yeah, let me go over this question really quickly, and yeah, I'll walk through the see in a second just to fix this problem. Okay, so first of all, we just distributed FOIL this right one more time. So square x times square x will be square bx, and then square x minus -8 is -8 square x. And 2 times square x is 2 square x. And 2 times -8 is -16. And now combine like terms, middle two are like terms. Everything else just stay as is. -8 plus 2 is -6, so x -16. Then again, if you want to go backwards, right? Sometimes you don't need to go backwards. You can factor this, return into the two factors. All right, so that's the answer for this x minus 6, so x minus 16. So x minus 6 square x and minus 6. Okay, yeah, that's good. So let me see. Difference of 2 squares. Yeah, let's try. I guess, yeah, we can try one of this. No problem. Let's start with this positive ones. All right, so you guys try this one really quickly. All right, so Cedar, I'm gonna put you in a breakout room, right? And then I'm gonna talk to you in private. Okay. So I'm gonna right now put you in, you know, breakout room. So let me see. I'm just gonna open the let me see. Okay. There should be a chat here. For some reason I couldn't find a chat option in our Zoom meeting. So I'm gonna create a breakout room for Cedar. So Cedar, you just join the breakout room and we can talk about it. Right?
Okay.
Yes. Okay. Mhm. Okay, Cedar, are you there?
Yeah, yes, Mr. I'm
Okay,
here.
so yes, I'm gonna go back to this. I'm gonna take a look at your account. So again, your username and password will be as your last name,
Yeah.
right? Mode. So your
Yeah,
password will be the CUNY first ID number.
yeah.
Okay,
But
so I'm gonna,
I try, but I can.
okay, so maybe you put in the wrong CUNY first ID number.
No, I try like several times.
So this is 24581149, right?
Yeah.
Okay, so I'm gonna copy that, and I know your first name. So let me just sign out. So I'm gonna sign in using your, like Cedar mode. What is how do you spell your last name?
Mahmud.
M-A. Oh, M-A-H. H.
Yeah, Mahmud.
Okay, yes. I see, I just pasted password. You see, this is your
Yeah,
password.
yeah,
22581149. Can you
yeah.
see get in?
But let me show you. When I try, I'll show my screen with you. Just give me a minute.
Sure, yes, yes. I wait on you. Yeah. I'm gonna stop share. You can share now. Mhm. S Mahmood. Just S and everything lowercase.
Yeah.
Lowercase, right? Yeah, everything lowercase.
I'll try again.
Okay, try that. Yeah. Okay, so let's go back to that question. Do you finish the question yet? Okay, so let's go over the solution on that question really quickly. So first of all, you're gonna square both sides of the equation for this question. And simplify as much as you can and solve for x. So square both sides equation first. Okay, on the left hand side, we get the x squared plus 14x adding 49. On the right hand side, we get 2x plus 77. I just subtract 2x, subtract 77 from both sides equation. And then we cancel that on the left hand side. On the right hand side, we get x squared plus 12x minus 28. Yeah, that's 28. That's right. Then we need to factor this factor trinomial on the left hand side. So this one goes like this. Factor next, that will be 14 and 2. 14 is positive, 2 is negative. And multiply, you get minus 28. When you add them, you get plus 12. So we get a right factoring here. So you get x plus 14 minus 2 equals 0. So x plus 14 equals 0, solve for x. X minus 2 equals 0, solve for x. X equal to minus 14, x equal to 2. So you do get two solutions, but we have to check it. So when we plug back into, I think one of them is not working, right? If you plug minus 14 back into the, so when you check it, when you plug minus 14 back to the original equation, like 7 equal to square root of. So sometimes, you know, you may create a false answer here. That's why you need to double check. If you plug in and minus 14 on the left hand side, you get minus 14 and 7. And that's definitely this is not allowed, right? This is disallowed. And then because it's square root. So the number of the both sides should be positive. Minus 14 and 77. And this is not okay, right? And the 7 is definitely not equal to this. Although we can just it's minus 28 and that's 49. So square root of 49 is 7, but it's not happening. Okay. So that means this answer is not good. So you're going to eliminate this answer here. And then we're going to check the other answer, which is 2. I think that one works. So 2 plus 7 plus 9. We don't know yet. So we're going to put a question mark on top of it. Times 2, adding 77. That's 81. That's a square root of 81. That's equal to 9. 9 equal to 9. That is good, right? This is the only solution allowed for this particular question here. So the answer is just going to be 2. Yep, it's perfect, right? Any question about this?
No.
Okay, very good. Let's see, it could get a little bit more complicated, like this one. Okay, let's try one of this. This one is interesting because we got to do it a couple of times before we can get to the proper solution here. So let me just screenshot this. Okay. So now, first of all, we square both side equation, just like the other one, right? We square both side equation first. And then on the left-hand side, we get rid of the square root, no more square root, which is good thing. So no more square root on the left. But on the right-hand side, once we expand it, so it will be square root x squared, that will be x minus 2 times 2, and square root x, and then 2 squared, right, adding 4. Okay. Now, we have x minus 20, then x plus 4 minus 4 radical x. Okay. Then we're gonna keep only the radicals on the right hand side, right? So we're gonna subtract x, subtract 4 on both sides of the equation. Okay. And from here, once we do that, then we cancel this, combine those, we get minus 24. Right hand side, we only have minus 4 radical x. Now we're going to divide both sides of the equation by -4. All right, so I'm going to cancel that. We get square root of x equal to 6. Is this okay? Square root of x equals to 6. It's not okay if the square root of x is -6, right? This is not happening, right? This is not okay. But this is okay. So you square both sides of the equation, get the answer, right? X equals 36. Then we could quickly double check. Check it. The radical x minus 20 equal to radical x minus 2. So throw in 36, you get 36 minus 20 is square root of 36 minus 2. So square root of 36 minus 20 is square root of 16. And this is 6 minus 2. This is 4, and it's 4 on the right. Okay, so we check it. So this is good. The solution is 36. So the answer is just going to be 36. Okay, you guys gonna try another one. All right. Yeah, try this. All right, guys, while we're doing this, I'm calling attendance. So, high test, are you here? High tech. Yes, yeah, I see you. Okay, I'll check in the list too. Okay, next one, Abra. Here. Okay. Amaya here. Okay. And then Michael definitely is here. And Milton is here, right? Yes. Okay. So Nasrat. Nasrat.
Mister, you call my name?
Yeah, I call your name. Yes, Nasrat. Yeah.
I'm sorry. I'm sorry. I didn't hear. Sorry. Yeah, I'm here.
Okay, sure.
Okay, sorry about that.
Yeah, no problem. Daniel is here, right? Daniel is here. And Septimonia. Septimonia is here.
Here.
Yeah, okay. Cedar here.
I'm here.
Yeah, sure. Okay, and then Ivan is here.
Here.
Yeah, sure. And Tom is here, right?
Yes, I'm here.
Okay. And Carl, are you here? Carl?
Yes.
Okay. Very good. And Victoria. So Victoria is here. Okay.
Did you get me?
Yes, I got you. Victoria, right?
Oh, the major.
The major. Yeah, I got you. The major. Yeah,
Okay, thank you.
sure. And Nisha.
Yeah.
Yeah, here. Okay, great. And Guang Yu.
I'm here.
Yeah, sure. Okay, great. Very good. So mark everybody. So let's go back to that question really quickly.
Sir, did you call my name? I'm sorry, I didn't hear you.
Okay, one sec. Victoria, yeah, I call you. I mark you, Victoria. Yeah.
Oh, sorry for not answering. I'm here.
Okay, no problem. You're here. I know.
How about me?
Michael, I got you.
I'm so
Sure, yeah.
okay.
I mark you. Yeah. I also check the list. You know, sometimes I scroll through the participants list, and then if I catch your name, I usually just mark you. So, so no worries, right? Otherwise, I would keep calling your name until you, if you're not responding, and let's say I couldn't find your name on the participant list, and then I will usually call second time. Yeah. So no worries. Okay. All right, so let's go back to that question. Let's figure out a solution here. Okay, so step one, you square both sides of the equation, and we get a much simpler version of the equation. So x minus 3 on the left, on the right is going to be square root of x squared is x minus 2 times 1 times square root of x, and plus 1 squared, that's 1. Let's simplify leaving that. 3x 2 radical x plus 1. Now we're going to get rid of both variables except the radical on the left, on the right hand side. So subtract x, 1, x. And cancel this, cancel that. This one is gone, x is gone. Minus 4 equals to minus 2 radical x. and divide -2 from both sides of the equation. X radical x equal to 2. Now square both sides of the equation one more time. And we get x equal to 4. So the answer is x equal to 4. And we're going to check it really quickly. So write out the original equation, radical x minus 3 equal to radical x minus 1. And put in the 4 here. Yeah. So 4 minus 3, square root of 4 minus 3, that's square root of 1. And then square root of 4 minus 1. We don't know yet. Question mark. Radical 1 equal to 2 minus 1. 1 equal to 1. This is definitely a valid equation, so that means our solution is perfect. X equal to 4. And that's the only solution here. So 4. Yeah, so that's pretty much on this section. And the last topic is on the complex numbers. So let me give you some brief introduction of the complex numbers. Yeah, I'll open one note. So I did. Okay. So let me share the screen with you. And complex solution is used widely, right, in a lot of quadratic equations. And later on, when you move on to pre-calculus and calculus, especially useful to find out the zeros of the polynomial functions. So complex, sometimes we may have a complex solutions. So it's widely used in zeros of polynomial functions. We are talking about those high degree polynomial functions, right? Like higher degree polynomial. This and then complex numbers. This is section 5.7 on complex numbers. Basically, it comes from this very it's not very normal concept, right? So we get I squared equal to 1, -1, right? So this is the foundation of the complex numbers or complex. There's a course called entire branch of mathematics called complex analysis. It's basically and it's very important because in the physics there's a matter and antimatters, and antimatters is almost like the complex numbers. It's like the other side of the real world, right? So that's why this is very important concept. And in the physics, there's famous, like black hole, and all of this is based on this complex system we have out there. So, and how this was first developed is coming from this equation, right? Let's say x squared plus 1 equals 0. And we know that x squared, that means if you get x squared by itself, you get -1. And in a real number 1, there's no solution here. Right? In a real number 1, there's no solution, no solution. We say no real number solution here. However, once people discover this complex system and complex numbers, now actually there's a solution, because -1 is equal to I squared. So basically we've got x squared equal to I squared. Now if you take in the square root, right, on both sides of the equation, then we come out plus minus radical I squared. And we end up with a 2 complex solution, plus minus I. And this is where the complex numbers was first discovered and used in mathematics. And later on, a lot of different fields, especially physics, they use a lot of this kind of like development of the complex numbers and complex systems, complex analysis they use in the physics. And this is the story behind the complex numbers. And this is the most important thing, right? I squared equals 1, -1. This is the main focus. So anytime, let's say we get a I cube, right? And we will find out what is I cube. Either as an I or as a number. So you get I squared times I, right? It's really as a I squared, and I squared is -1. So you get -1 times I. So you get -I. And then let's say I to the 4th. And we know it's I squared times I squared. Then it's -1 times -1. It becomes 1. Right? So this complex number actually is very interesting because then I to the 5th, what's I to the 5th will be I to the 4th times I, right? I to the 4th, which is 1. So it's 1 times I, that's I. If you keep going, right, I to the 6th will be I to the 4th times I squared. And we know I squared is -1. I to the 4th is 1. So 1 times -1. Then again, go back to -1. So you see, there's a like alternate cycle. There's a cycle in this complex numbers. And let me quickly just erase this. And it's sort of like on a very nice pattern here. Along the way, right? I squared, that's -1, then we get -I, then 1, then I, right? And then -1. Now if you do I to the 7th, will be I to the 4th times I to the 3rd. And we get I to the 4th, -I, and that, so it's -I times 1, -I. And you see it repeats, right here, -1, -I, 1, I, right? That's the pattern here. If you keep going, I to the 8th will be I to the 4th times I to the 4th. Now, naturally, you should go back to 1, right? So we 1 times 1, that's 1. Then I to the 9th will be I to the 8th times I. So I to the 8th, which is really is 1 times I. So it's I. You see another cycle here, right? So it's a cycle is starting with the I squared all the way to I to the 6th. That's one cycle, and this is the second cycle. It's built based on the first cycle. This is basically the structure of the complex numbers. So now let's go back to the exercise here. Let's do some exercise involving the complex numbers. And then we do have some operations, right? I will talk about that in a second. Let's start with the problem 1 here. Okay, so this is a typical like application of the complex numbers. Let me show you how to handle this. So typically, anytime you see right in terms of R. Okay, so I'm gonna first of all rewrite it as. So it's very neat transformation here is anytime when you see negative sign, you can break it down as number times -1. So here you're gonna write it as 81 times -1. And we know I squared equal -1, or -1 equal to I squared, right? This is very, very useful transformation here. So we're gonna stick with it. Anytime it's -1, it's I squared. So go back here, it will be radical 81 times I squared. Now it's split as two radicals, radical 81 and radical I squared. Radical 81 is 9, I squared is 9. So again, 9i. Okay. And so this right in terms of the I, we get 9i. Yeah. And just remember, I is a complex number. So this is 9i, right? Yeah. Lowercase. And let's check it. And that's good. I guess you guys gonna try one of this, right? Try another question. All right, so that's quickly check the solution. So you're gonna write it as 16 times -1. And so -1 equal to I squared. It's 16 times I squared. And square root of 16 is 4. Square root of I squared is I. So the answer is 4i. Okay. And check it, so it's good. Now let's look at another type of question. So this one is a complex number, but it's not a perfect number. So let's try this. Okay. So again, it's similar procedure, right? First of all, you break that as 98 times 91. You try to call 98 times -1. And -1 is I squared, so it's radical 98 times I squared. So now we get to break down 98 as 49 times 7. 49 times 2. That's 98 squared. And square root of 49 is 7. And then we're going to put both perfect terms together, right? Perfect number, perfect term, 49 squared. And then times 2. 2 stay under radicals. So radical square root of 49 is 7. Square root of I squared is I. And then times radical 2. Okay. So it's split out as our people usually will write it as 7 radical 2 times I. That's probably more proper way of writing this. Just put an I on the side, on the right hand side. So the answer here will be 7 radical 2. Okay, so let's try another one. Okay, you guys try this. All right, let's go over the solution. First of all, we're gonna turn this as 162, and that becomes 162 times I squared. Now break down 162, right? It's the maximum perfect number will be 81 times 2 I squared. Now rearrange it, put both perfect number 81 and then I squared together with the 2 on the side. So you get radical 81 is 9, radical I squared is I, and then radical 2 remains under the root. It's 9I radical 2, but usually we write it as 9 radical 2I. So I guess we can keep as this and just get to this answer directly without rearranging. 9 radical 2I. Let's do it. Okay, let's see. Next question. AI to the 11. Okay. So what will be the best way of doing this? Any suggestion?
-1.
-1? Yeah. How do you know it's -1?
Because like I square is always like -1. So whenever whatever power you put like on I11 or I100, it should be -1. No change.
If the even power, right? That could be possible, but here the odd power, so probably not. Okay, but let's see, right? I actually I'll do that step by step. Okay, so one way to look at it is you're gonna split that as I squared times I to the 10th times I to the first. So just break down as I to the 10th, get an even power, and then I to the first. And then I to the second, you can write it as I squared to the 5th. Just like A raised to BC power, right? Could be A to the B raised to C power. Basically, just split 10 as 2 times 5. So I 2 times 5, and I squared to the 5th power. And we know this is I. And I squared is -1. -1 to the 5th times I. -1 to the 5th, that's -1. So it's negative. So the answer should be this. What option? Okay. So always, right? Split like this. If it's odd, do that. If it's even, let's say I to the 12, that's even better, right? We just do I 2 times 6. And we do I squared because we know what I squared is. So it's -1 to the 6. Any negative number to the even power becomes positive. So 1 to the 6. So that's how you really deal with these complex numbers. In this case would be -1. Check the answer. It's good, right? So you try another question. Let's see. Okay, I to the 16. Yeah. Okay, any suggestion? What's gonna be the answer? So it's even powers, basically you're gonna do 3 as I 16, that's I 2 times 8, that's in terms of power wise. we're gonna do it as I squared to the 8th power. On the I squared, we know it's 1. And we want to the even power between part of it. So the answer is just part of 1. Okay, so let's see what else. I to the 62. No, let me try a different one. The 46. Any suggestion?
I'll say 1.
Oh, 1, right? Very good. You sure? One more time. How do you get 1? So 1I 2 times 23, right? And that's I squared to 23rd power, right? And we get I squared negative 1 to 23rd power. So what do you think? Will be negative 1, right? It's a negative number to the R power remain negative, and then 1 to any power will be 1. Okay, so it's a negative 1. So the trick is once you divide by 2, if that number is even, then you get 1. If the number is odd, you get negative 1. Right, so that's a pattern here. So that's why this should be negative 1. Yeah. And let's see, next. Yeah, so this one we have so we're gonna deal with the complex equation, right? Okay, so let's do it. Let's see. So you have equation here, so we're just equalizing both to another. No, it's okay, that's okay. We try to find out x and y. On the left-hand side, we get x and y. On the right-hand side, that just it's a complex number. So a typical complex number will look like this: a plus bi, right? And the a is called the real number part. And then bi is called the complex part. Complex number part. So a typical, any complex number could be written as this: a plus bi. You have a real part and then complex part. And right here, yeah, sure. Question?
Oh, we can see, sir.
Oh, yes. Forget it's correct. Yeah. Okay, so thanks. So a plus bi, that's a typical standard notation for complex. Notation for complex number. A plus bi. And right here, a is what we call the real number part. Bi is called the complex number. Right here we distribute it. So you get minus x minus yi equal to 1 plus 9i. Now, in order for two complex numbers to equal to each other, we actually got to make sure the real part equal to each other, right? So negative x must be this. Negative x must be equal to 1. And then we're going to make sure complex sides equal to each other. So minus y equal to other. Just the number part, right? So I we can omit that, and based on that we can get the values for both x and y. So here you divide everyone from both sides of the equation, x equal to -1. On the right hand side, you divide -1. You could also multiply -1, either one you like. So y equal to, and plus minus is minus. So it's minus. So x equal to -1, y equal to -9. Any question about this? -1, -9. Check it. It's good, and then let's try another one. Okay, so you guys try this one really quickly. All right, so let's look at a solution for two complex numbers to each equal to each other. A plus bi equals c plus bi. Then a must be equal to c, and b must be equal to b, including the sign. So that's guiding principle. So for, to get the value of each one of the numbers here. So here 4x must be -8. That's the real part. And the other one is -7y must be equal to 63, positive, right? 63. I should take the coefficient in front of I. You can omit the I. That's okay. And I will divide the first one, divide 4 from both sides. 2. And for this one, you divide -7 from both sides. Y equal plus minus 63 by 7 is 9. -2, and it's 9. So that's the answer. Yeah, any question? All right, so now we learn how to add into complex numbers. Okay, so new version. So when you add two complex numbers, first of all, you add a real bar, and also you add a complex part, 2 parts. So first of all, let me show you the overall principle here. So let's say you have A plus BI plus C plus DI. So you put a real part together, A plus C goes together, and then BI plus DI goes together. And for the complex part, so keep A plus C as real part, and then factor out the I, and then remains whatever remain inside the scope parentheses with B plus D and I. That's how you add two complex numbers. Two complex numbers. So you get this. And very similar here, we just adding the, so work on the left hand side, right? Adding 8 and 8, you get 16. And then 9i and 9i, you basically add a coefficient. So a lot like 9x plus 9x, right? You get adding a coefficient, you get 18x. Same thing here, we add 9 and 9, you get 18i. That's the result on the left hand side. On the right hand side, A plus BI. Now they are equal to each other, so real part equal to each other. A equals 16, and B equal to 18. Complex part equal to each other. So 16 and 18. But you should add them first, right? Adding them first, and then put it together. $16 and $18. Now let's take a look at another one. You try another one. Try this one. All right, let's go over the solution. So you do 6 plus 8 is 14. 4i plus 2i, that's 6i. That's equal to 8i. So A equal 14. B equal to 6. Very straightforward. Let's move on to the next 46. Yeah, let's look at question 7. And still addition, so we're gonna skip it. We're gonna look at this subtraction one. This one is a subtraction. Show me another. Yeah, this is actually kind of interesting. So let's look at this one. Okay, so when we subtract two complex numbers, A plus BI minus C plus DI. And basically, you put back the invisible one and distribute it, so you get A plus BI minus C minus -1 times positive D is minus D. Again, you put a real part together, so you get A plus A minus C together. Other one, you put a complex part together, BI plus BI. No, minus DI. From there, you will just factor out the I. It's A minus C, D minus D, and then I goes outside, right? So this is real part, that's a complex part. Yeah, real complex. Yeah, that's how we basically do it. So here it is oil, this we remove the one, so we get 5 plus 9 minus 9 minus 9. That is equal to A plus B. So that 5 minus 9 is -4. 9 minus 9 is 0. You can write 0, right? But usually it's easier here to write 0i because we still gonna want to know what is A or is B. So A is -4. Then B is -0, but which is 0, B equals 0. That's basically how you deal with subtraction of two complex numbers. So it's -4 and 0, -4. -4, 0. Answers, they both good. And that you try another one. This. All right, let's check the solution. First of all, we back the one and then distribute it. There. So we get 7 plus 1i and then minus 4 minus 7i. Right, it's 8 plus. Now subtract 7 by 4, you get 3. 1i minus 7i is minus 6i. So that's 8 3i. And then A equal to 3. And B equal to -6, not 6, right? It's a tricky thing is that sometimes you forget to put a sign, but if the sign is included, it will be -6. B equal to -6. 3 and -6. always include a sign in front of the I. Okay, this is good. And we're gonna see multiplication division soon. It's still I guess I can leave this to you guys. And let's look at next question. Yeah, so we're gonna start having multiplication, right? Multiplication of the complex numbers. All right, let's look at it. So this is typical multiplication of complex numbers. Let me just show you a general principle, right? Let's say you multiply two complex numbers, a plus I times c plus di. This one, no numbers. Okay, so a times c give us ac plus a times bi get adi, and then bi times c is plus bc times I, and then bi times di, that's bd times I squared. Now we know I squared is -1, so it will become ac. Middle two are like terms, and then bd times -1 is minus bd. So this is a real part. And then the complex part comes from the middle two, right? Middle two, you just factor out the I, put it outside, and inside the parentheses will be AB plus BC. So this is the real part. This is the complex part. That's how you usually multiply the two complex numbers. And here we have an easier version. So -7i times 2 is -14i. And then the other one is -7i times +6i minus +6 minus 6 times 7, 42, and I squared. I times I is I squared. And we know I squared is -1. Yeah, it's -14i minus 42 times -1. From here, this 2 minus become plus, so it's 42 positive, real part -14. So it's 8i. Now a equal to 42, right? A is real part. And b I as complex part. So b equal to -14. 42 and -14. 42 here, -14. Any question about this? 42 -14. All right, so you guys try another one, a similar one. Okay, let's try this. All right, let's go over the solution. So here you can put negative sign in front of it, right? And it would make it slightly easier. So minus like and then 8 plus 7. So negative 7, 5 times 8 is minus 56, 5. Plus minus, minus plus is minus. 7 times 7, 49. 5 times I squared. We need to simplify because -1, I squared equal -1. This is the most important thing, right? It's like the foundation of all the complex numbers. So that minus 56i minus 49 times -1. Yeah. And that's this is 49. So it's 49 minus 56i. So A is 49. B is minus 56. 49 and minus 56. Any question? Okay, so let's look at next question. Probably have a division also. This one is just it's a complete, right? It's a complete two. You multiply two complex numbers. This is more like the one I showed you earlier with the standard form, two complex numbers, multiply them and simplify afterwards once we expand it, FOIL this. So -2 times -3, it's 6. And then -2 times plus 6i, that's minus 12i. And -7, I mean 7i times -3, it's minus 21i. And the last term is plus is plus. 7 times 6 is 42. I times I is I squared. That is equal to 8. Now combine like terms. These two middle two are like terms. Minus, we end up with a 33. And then I squared is -1, so it's 42 times 1. Now 42 times 91 is minus 42, 33i minus 42, 8 plus 3i. Now 6 minus 42, that's minus 36. Now A should be negative 36. B is minus 33. Okay. So minus 36 and then minus 33. So simplifying, combining like terms, that's important step in the middle. So that's how we get to the bottom of this question. So minus 36, minus 33. Old negative. Yep, it's good. So you guys can try another version of this. Give a shot. This one have a multiple, or if you want, you can distribute this one first, but distribute it. Okay, try it. Right, let's go over the solutions. As I mentioned, you could do this, right? Distribute this -1 into both, and then make it slightly simpler. So -4 plus 3i, and then the other one is -1 minus 3i minus 8 plus bi. Now start for your base, -4 times -1, it's probably 4. -4 times minus 3i, that's 12i. And then 3i times -1, that's minus 3i. 3i times 3i minus 3i, so it's minus 9i squared. So combine like terms, below 2 like terms, yeah, combine them. So, and here I squared is -1, -1 times -9, that's 9, 4 plus 4 minus 3 is 9. And this is plus 9 equal to 3. And 4 plus 9, 13, adding 9. Now A equal to 13. B equal to 9. So, yeah, no matter how complicated it is, but eventually you're going to come down to a simplified complex fraction with a real part and complex part. So 13 and 9. So I haven't done any division yet. We'll get to that in a second. Yeah, so now it's here though. So next one is a division. So divide two complex numbers. All right, so another. Let's see. So the typically is we just multiply the both top and bottom by the complex conjugate. So let me show you how that goes. The complex conjugate, right? So so it comes from this. So let's say a plus bi times a minus bi. We're still using the difference of two squares. And if you do this, it's a plus b, a minus b. So it's a square plus, no, minus, right? A square minus b square. So minus bi square. If you simplify, it will be a square minus b square times I square. So this is a square minus b square times -1 becomes plus b square. As you can see, once you multiply, once you form a complex, form the difference of two squares using the complex numbers, we actually get rid of the I. I is no longer here. I is gone, right, at the end. So these two are what we call the complex conjugate, a plus bi and a minus bi, called it complex conjugate. So in order to rationalize the denominator, we always need to multiply the denominator by the complex conjugate of the denominator. So here we get I, so the complex conjugate in this case will be -1, right? It's like a 0 plus I, right? And then that will be 0 minus I, which is -I. And this is I. So that's why the complex conjugate of I is minus I. So that means from here, so we're taking 3 plus y I times -I times -I here. Okay. Multiply both top and bottom by the complex conjugate. Just like a rational expression, right? We multiply both top and bottom by the, like the radicals we did earlier, right? Like I say radical 5 on bottom, right? 3 plus radical 3. And what we do is multiply radical 5. Same idea here, right? And then we get rid of the square root on denominator. Exact same thing. Once we multiply both top and bottom by -I, so we get -I squared on the bottom Negative I squared is positive 1. And here distributed negative 3 times negative I is minus positive 3i. And then 4i times negative I is minus 4i squared. Yeah, so carry over this because I squared is negative 1, so on the bottom it becomes negative 1. On the top will be 3i plus 4. This is I squared is negative 1. Negative 1 times negative 4 is 4. And then you're going to rearrange it 4 plus 3i as a complex number over 1. Since it's over 1, so we omit it. 4 plus 3i. This is equivalent to a plus bi. Now a is 4, b is 3. It's going to be 4 and 3. Okay. So that's how we tackle these division problems 4 and 3. Yep, that's gonna go. So you're gonna you try another one. So you gotta try this one. And let's go over the solution here. So I'm going to show you a different aspect of this, right? Here, if you put the negative sign at the bottom, it makes it so much easier. I'll show you how. Negative I. If you put a negative I on the bottom, and you multiply both top and bottom by two. So A plus BI. Now negative I times I, then we get negative I squared. In the bottom. And you automatically turn into positive one. I squared is negative one, and negative I squared will be negative one. So it's positive one. So on the top it will be 2 times I 2I plus 3I squared. And bottom we just check that it's 1. So it's 2I squared negative 1, negative 8 over 1. Any number over 1 is itself. So we end up with minus 8 plus 2I. Turning to a standard notation, real number, complex number equal to A plus 3I. So now the A equal to negative 8, and then B equal to 2. Nothing wrong, right? If you just you're just going to multiply by negative I here, right? Just if you go the other way, then you just have more signs to deal with. Nothing major here, but just you can sometimes you can do a little bit of a proper arrangement just to decrease the difficulty level. Okay, so it's minus 8 and 2. All right, so that's question 12. It's perfect. See, 13 is very similar, so we're gonna skip it. And we're gonna try this one. This one is something we haven't done yet. Basically, we have a standard notation on a denominator for, so we get to multiply both top and bottom by the complex conjugate, just like the other one, but with a slightly more complicated nature. Like this one. So first of all, you determine the complex conjugate here. And that's going to be 6 plus 2i. I'm going to multiply both top and bottom by 6 plus 2i, so negative 5 over 6 minus 2. Multiply by 6 plus 2i top, and 6 plus 2i to the bottom. And A plus bi on the right. Now, on the bottom, so if you want to do that on the side, no problem. We can just quickly do that on the side. It should be A squared minus B squared, so it'll be 6 squared minus y squared. That will be 36 minus 4i squared. And then I squared is negative 1, so it's 36 negative 4 times negative 1. That's 4. So 36 adding 4, that's 40. We get 40 on the bottom. And the top will be minus 30 times 10 over 40. I'm going to split it as minus 30 over 40 is minus 3/4. The other one is minus 10 over 40 is minus 1/4. Now A is minus 3/4, B is minus 1/4. Any question about this? Minus 3/4, minus 1/4. So that should be good. All right, so I let you guys try similar question. Do you have to try this? Notice that this is not the, it wasn't set up properly, right? So it's probably rewrite this as -8 plus 3i. Okay, that's very important. -8 plus 3i. Otherwise, it will look very confusing. Yeah, give a shot. Let's go over the solution. As I mentioned earlier, I can rearrange it, but right, we get 8 first, plus 3i. Now, the contrast conjugate here will be -8 minus 3i. Then you multiply both top and bottom by the contrast conjugate. So -8 minus 3i top, and the bottom is -8 over 3i. That is equal to 8 plus 3i. From here, and we just take out this, right, and then it's just simplify. -8 minus 8 minus 3i. That will become a plus b, a minus b. So a squared minus b squared. So this is a squared 64 minus 9i squared. I squared is -1, so 64 plus 9. That is 73. So on the bottom is 73 and distribute it. We get 16 plus 6i over 73 equal to 8 plus 3i. Then we're going to split it as a 16 over 73 plus 6 over 73. So here A is 16 over 73 and B is 6 over 73. Okay. Any question? That's how we divide the two complex numbers using the complex conjugate. We check the answer. It's all good. All right, just one last, you try this one, and then, yeah, let's give a shot on this. So both top and bottom are complete complex fractions, complex numbers. Okay, let's go over the solution, and I'm gonna show you the midterm practice, right, in the website in a second. So I'll just check into the system, it's there already. So let me go over this question. And then I can show you where the midterm practice is. And then we're gonna review that next Tuesday. Yeah. Okay, so first of all, the complex, we're gonna rewrite the bottom, right? I said, so 6 plus 6i. Top on the bottom, we're gonna write it. Minus 6 plus 2i. So the complex conjugate is gonna be -6 minus 2i. And then quick shortcut to this is if you, without doing all the detailed work, it will be, this will become a squared, right? This is a, that's b, will become a squared plus b squared. So the shortcut is it becomes -6 squared plus 2 squared. So it's 36 plus 4, always equal 40. Because a plus bi, a minus bi, we did expansion. Notice that it's going to be equal to a squared plus b squared. So that's why this is a, that is b, and that's what we have here. So we get 40 on the bottom. On the top, we get a 40 of this, right? So 6 times -6 is 36. 6 times -2i is -12i. And then 6i times -6 minus 36i. And 6i times minus 2i, that's minus 12i squared. And we're still gonna do some simplification before we get the final answers. So here, combine the middle two terms. So minus 36 minus 48i minus 12 times -1, it's positive 12 over 40, and that's 8 by. Then combine one more time, minus 36 added 12 is minus 24, minus 48 over 40. That is 8 by. Now reduce it, right? Minus 24 over 40, they both could be reduced by 6, so actually 8, right? So you get minus 24 over 40. Let's do it slowly. Minus 48 over 40. Reduce it. Both of this could be reduced by 8, 3, 5, minus 3/5. And both of this could be reduced by 8, 6, and 5. It's minus 6 over 5. Now A is -3/5, B is -6/5. So A equal to minus 3/5. And B equal to minus 6 over 5. That's basically this answer here. Go back, let's put in the answer, check it. Let me show you one last thing before I let you go. 3 minus 3 over 5 minus 6 over. Check it. And both good, right? Okay. Any question? Before. So if you log on to the website, then you're gonna see Professor Dawes, he upload 3 different kind of like practice midterm exam with help, this one with help, no help. And then we're gonna go over some of the questions. I'm gonna go over questions from the practice midterm next Tuesday, right? July 16th, and get you ready for that. He also posted trial Net56 midterm lockdown browser file upload just to help you get used to this system. So by the time you get to the final, you can easily upload your files. So that's why I use a midterm as a practice both for the system, also to prepare for the actual midterm. Okay, everything is here already, 3 different versions, and yeah, so he hasn't uploaded actual midterm. Yes, he will do that next Wednesday, right? Okay. Do you have any questions before we end the section?
Mister, I have the question about my web work.
Web work? No. Yes. What question? What about your web work?
Like you said me that you're gonna send me an email about like web work because I put my username and yeah.
I did. I sent it to your personal, BMCC email like a while ago. Like 2 hours
What's
ago.
the email address that you send it? Because I checked the spam and all my inbox, but I didn't get anything.
What? I sent it to your BMCC email. Let me show you, right?
Yeah.
Okay, I can go back to my email. So let me show you right now. I sent it. This is the email I sent it to you. This is straight from my email, and this is cedar.mamu49@stu.bmc.cu.edu.
Oh, the thing is that I don't have this email access. Like where I can find this email, I don't know my email of the BNCC. I'm so sorry. I only have my personal
Okay, no
email.
problem. I'll help you with that. So for the rest of you guys, have a nice weekend. Okay, I talk to you guys on Monday. But Cedar, you stay, right? I will help you out.
Yeah, oh, no problem.
Okay.
Have a good weekend.
Have a
Thank
nice
you.
weekend, guys. Okay, bye-bye.
Thank
Bye.
you.
Sorry, I have a question. We have the midterm on the web work, right?
Web assign, yes, not web
Oh,
work.
website.
Web
Yeah.
assign, yes. I just show you it's on the web assign.
But
Because
can you
file
show
is on
me
web assign,
again?
so it's better, it's not that you start getting used to the environment, like web assign environment. Yeah.
Can you show me again because I didn't see.
I just yes, but I will show that one more time on Tuesday and then Wednesday. It's right here, right?
Oh, okay.
Yeah, so no worries. When you log on to use the link I send it to you, and then log on to the
Yeah.
website, and all the assignments has been posted. Yeah.
Okay.
Yeah. Okay, but don't worry. Next Tuesday we're gonna do this one more time. I'm gonna walk through this step by step, so you have access to the system. Yeah.
Okay, I get it.
Okay. Yes. Okay.
Thank
very
you.
good. No
Have a
problem.
good one.
Have a nice weekend. Okay. All right, guys. You can sign off if you have any other questions. I'm gonna help Cedar to set up his email.
I'm so sorry, Mister, about the mistakes.
Yes. So one mistake. So you want me to forward this to your personal email? So if you have difficulty, right, accessing the BMCC email, you should contact the tech support.
Yeah, because I don't know the email that like BMCC. I don't know my BMCC email. That's why I don't have access. That's what I'm saying. Like
What is your personal email?
Sigdar Mahmoud.
Cedar.
Yeah, Imam 2004 Mahmoud MAHMUD 2004
right?
at gmail.com. Yeah.
Okay, so I'm gonna send it over. Okay, so check your Gmail right now. I just forward you the email.
Yeah, I'm gonna check it right now.
Yes,
Yeah.
check it right now. I want to make sure you get this email.
Yeah, I got it.
You got it, right? Very good. So
Yeah.
if you have an issue with this BMC email, you should go down to the main building on the first floor. There's a help desk. They can help
Okay.
you recover your BMC email. You should do that though, because most of I think all of the professors will send an email to your BMC's email because that's what we have in the.
Yeah, I
School
know
first.
because when I was in high school, everybody sent the email to my school email, not in
Mhm.
personal email. I know it, but I don't have access, so I need to talk with them for fix it.
Yes. Go
And
down
I
to
and
go
one
to
more thing,
field
Mr. I need to
number.
click on the link, then I will be see then I will put my username, then
Yes,
I will see
yes,
that, right?
Yes, yes, exactly.
All right, because I didn't do any homework until now, so I have to do it like early, whatever I can.
Okay, so you still have
Okay.
some weeks, right? This weekend.
Yeah,
so you
I
can-
will do it one this weekend because I was not sure. That's why.
Okay, very good.
Thank you, Mr.
Okay.
I really appreciate it. Thank you very
No
much.
problem. Okay, I'll see you on Monday.
On Monday. Thank you, Mr. Have a good night.
No problem. Bye.
Bye bye. Bye bye.
Okay, bye guys.